Hi, it's Graham Cox here. I've got an interesting AgEarth case study here looking at erosion on a field in Central Queensland. This is the storm simulation on that field, but if we look at the topography, or if we look at the existing field, that's what it looks like. You see they're doing control traffic in this direction here. Control traffic is running the tractor on the same wheel tracks using RTK GPS guidance. Continuously. It has a lot of benefits, but one issue it does create is the wheel tracks become so pronounced that they can concentrate water flow. So this is the same view on Google Earth. If we zoom in a bit closer, you can see that's the wheel tracks, and they do build up over time, and the water can actually run into those wheel tracks, which concentrates, and then where we can actually get this type of result here. So if we look at the topography, that is the topography smoothed out slightly. It's actually original data was from LiDAR, but we've smoothed that out a bit here, and then we can simulate on that for a storm event, the water depth and velocity. And you can see here that the colors here are basically the water velocity in that area. And for bare soil, once you start getting above a velocity of about 0.5 meter per second, you can start to get erosion risk. So you can see it's building up, not too bad. Once you get into red, it's definitely higher erosion risk. And if you look at the topography the aerial photograph, satellite image in Google Earth, you can see there is some erosion happening at the end of these wheel tracks as the water comes out. But also up higher in the field, you can see some wobbling there, and that looks like erosion as well. It's occurring. There's also a flow path across here, but that's water coming from outside the field generally. Or then again, it could be coming down here, this wheel track, and then cutting across. So it just shows you how wheel tracks can impact erosion on these higher sloping fields. The slope we're talking about here is upwards, of 2% in some areas. Actually, here it gets above 2.5%. So the other unique capability of AgEarth is the ability to simulate these wheel tracks. So if we look here, I've got furrows and beds turned on, and I've got basically I'm representing those wheel tracks in a shallow furrow, only 50 millimeters high, and that wheel track is 0.3 of a meter wide every 6 meters. There's actually 2 wheel tracks every 12 meters, but we've represented that as 1 wheel track every 6 meters here, so we can put that in, and actually the simulation incorporates this into the calculations. It's not actually burned into the topography, it's just incorporated in the simulation. So you'll see if I turn this off and I rerun this simulation, it's a totally different result. So we're not getting this concentration here. The water's dispersing to the side, and it's not concentrating that depth, even 50 millimeters deep in the wheel tracks is enough to concentrate it. It's spreading out more. Here we do have a bit of risk, but there's only a speck of orange there, and here this is where it gets steep too. But the impact across the whole field for the wheel tracks is significant. when you have the wheel tracks on. The other sensitive, there's some other parameters that go into this simulation. The other sensitive one here is this roughness. If you can keep the field rough, as in stubble and vegetation on top, you can make the soil a bit rougher. That's what this can be represented by. You can see the higher velocities just disappear. Bare soil is normally down around here, and that's so the solution here is to add contour banks. So that's these, they're actually graded contour banks, so they're designed to catch the water as it flows down the hill. They'll catch it and they'll take it down on a slight grade. So these contour banks are designed at a slope of 0.15%, so 150 millimeters in 100 meters towards this edge, and then this grassed waterway will take the water down the slope. Because it's grassed, it can handle higher velocities. So these guidance lines can be exported to a number of different file types to be loaded into GPS guidance systems for tractors to guide them along those lines to mark these contour banks out, and then they get built with an earth moving implement. The next iteration on that is actually putting vertical control on these. Like instead of just providing horizontal guidance lines, we can provide 3D control files that go into the earth moving machines to control the blade height, as well as they're building this. In this case, the client just wanted guidance lines. Now, if you'd like to try this tool, just go to Google and type in AgEarth, and the top one should be this one. Click through and you should land on this marketing page, and then you can get started for free. Okay, thanks for watching, and let us know with any comments or any questions below, or email us at support@optisurface.com. Thank you.